Hello everyone, this is Joe Parks. Since we've been snowed out today, I thought I would try to do a series of short videos on what we might have covered. You are responsible for the reading, all of it, and um, what I'm just going to try to do in these videos is hit the high spots for things, for some pointers of topics that are super critical. Not to say that any of the others aren't critical, but these are sort of foundational. If you don't get those, you won't understand the others either. So this first video is going to be on Chapter 2, Primitive Data and Types, and I'll do another one on operators and so forth. If you've not brought up Eclipse, you might want to pause the video and bring up Eclipse and create a project. That's what I have here. I created a project called CSC Ch02Lecture. So I am going to start off and create just a class that I can play in. We're not going to be doing very much in this video except declaring some variables and showing what some things that work and some things that don't. And this video will be concentrated on primitive types. There are two major types in Java, two major types of types in Java. One are called primitive types, which are the simplest, and the other are referred to as object references or object types. And some object types are built into the language, such as string, which we'll talk about a little bit today and even more for Chapter 3. Other object types are things that we write, so we may want to write a book object or something like that. The major um, numbers in Java, there are two major flavors. One are the numbers that cannot have a fraction, and the most commonly used one of these is called an int. Others are byte, short, and long. They differ in how much memory they take, and I'll let you look at those in the book. There are numbers that can have a fractional portion, and there are two of them. The one we'll use is called double, and the other one is called float, and they differ in how much memory they can take and how granular or fine or precise a number they can hold, how many significant digits, and how big the exponent can be. Think of a double or a float number as something akin to scientific notation, where you might have um, something like 3.14 times 10 to the 10th power or something like that. And I wonder how I can represent that since Java doesn't have an exponent. Let's put that to the 12th power. So this would actually be a very big number. Even though it's written as 3.14, it's got 3, 1, 4, and then 10 zeros after it. So those are the two kinds of numbers we can have, with fractional portions and without fractional portions. A couple of other kinds of primitives. Um, A Boolean can have a value true or false. One word of warning for those of you who may know another language: there are no numeric equivalences for Boolean true and false. TRUE and FALSE are all you get in Java. I know of no way to figure out exactly what numeric value a JVM is using for a Boolean true or false. And one that we'll use very sparingly is a car, and it holds a single character. A single character literal is something in single quotes like that. ASCII is not, Java, is not, well, I can't type. Java is not an ASCII language. It is a Unicode language. Characters take 2 bytes. So that's basically what we'll be working with. A couple of other points to make. Variables in Java must be declared exactly one time. So if you haven't declared a variable and try to use it, you'll get a compiler error, such as if I try to use f is equal to 5 here. This is a compiler error, and the compiler is trying to tell me that f cannot be resolved to a variable. Another thing I want to make sure you understand is that variables have to be declared exactly one time, which is what I just said, but the flip side of that is they cannot be declared twice. So if Java, or if the compiler is telling you that I can't understand your variable f here, and you've declared it, don't declare it again. That means that there's something going on where you think you have a variable that's valid at a certain point, and the compiler is telling you no, it isn't. Declaring a variable a second time, unless you want 2 different variables, is always a mistake. The other thing I want to talk about is syntax. A variable declaration, and this is true of primitive types or of object references that we'll get to later. A variable declaration is a type followed by an identifier, and it can have an optional initial value. And so here, for example, the type is int, the identifier is I. Here the type is double, here the type is Boolean, here the identifier is I like snow. I can optionally initialize these. I can declare an int j, and I can say that it will be equal to 5. I can declare an int k and say that it will be equal to j times 4, for example. So the initialization, which is followed by the equals sign here, and we'll talk more about equals later, is optional, but the declaration of a variable exactly one time is not, and the syntax of that declaration is type followed by identifier, and the rules for identifier are in the book. So I'll end this video here, and we will pick up on the next video with data conversions and casting. You might want to look over those in the charts or in the book before we start. Hope this has helped.